Right, good afternoon, guys. Today I'd like to talk to you guys about bonding. Okay, bonding is when two or more atoms join together to form a new product, and we've been talking about chemical reactions recently, and this is going to be a really important part of that. In order to create a new product in a chemical reaction, we have to break bonds or we have to make bonds. So it's important that we can understand how these bonds work. So today we're going to talk about one particular type of bonding, which is called ionic bonding. Okay, so as well as needing to understand what bonding is, we need to understand what ions are. So there's going to be a lot of a recap from some of the chemistry that we did earlier in the year. Can I ask that if you haven't already got paper and pen in front of you, or a book and a pen, something to write on, then could you do that now? Okay, so if you haven't, can you pause the video quickly while you get it? Okay, let's do a quick reminder about drawing atoms. Okay, now atoms have all got a nucleus, and in that nucleus there are positive protons and there are neutral neutrons. But what we tend to draw, because it's the most important part for chemistry, are the electron structure around the outside. Okay, and remember, the electrons uh, occupy shells around the outside of the nucleus. And you might be asked to draw the electron configuration or the electron shell diagrams for any atom. So let's take, for example, sodium. Now, sodium you could look up on the periodic table and you could find that this is element number 11. Now, the fact it's element number 11 tells me it has 11 protons and 11 electrons. We don't need to worry about the protons. They're all at the center of the nucleus, and we're not going to ever draw those when it comes to chemical reactions, but we are going to draw the electrons. So we have to remember the rules about where electrons go. And that is that you can only have 2 electrons in the inner shell, 8 in the next shell, 8 in the third shell as well. Now, because we've got 11 electrons here, we're going to put 2 in the first shell, 8 in the second shell, and that leaves 1 left over, and we draw it like this. Now, I've drawn them as crosses here. Okay, you can draw them in as dots as well. Uh, Once we've put 4 electrons in any of the 8 shells, we start to pair them up. You notice on the diagram I've got there. In the innermost shell for sodium, the diagram's not actually very good because I've paired them up in the inner shell. Normally, when we draw them, we keep them separate until until we get to the second shell. Anyway, that's sodium. Okay, so 2 electrons in the inner shell, 8 in the second, 1 in the next. How about this one? Fluorine, element 9. If you can just pause the video for a second, have a think about it, and you can draw for yourself on your paper what you think fluorine is going to look like. Right, hopefully you guys have made a drawing of that. So the configuration for fluorine is going to be 2 in the first shell and 7 in the second. We don't have enough electrons to fill that second shell. And so it's going to look like this. So 2 electrons in the innermost shell, okay, and then we're going to have 7 in the next. Okay. Okay, I've put on the board here a periodic table. Now, this periodic table is a little bit different to the ones we've seen in the past. We'll talk about how a bit later on. But all the elements are in the same position. So on the left-hand side at the top, you've got hydrogen, going down lithium, sodium, and so on. So all the elements are just in the same positions we've seen before. There's just a little bit more information we'll talk about later. Now, on the right-hand side, I've put a diagram of a sodium atom. Okay, remember it's got electronic configuration 281. So 2 electrons in the inner shell, 8 in the next shell, 1 in the further shell. Now, what I want to do is relate the diagram of the electrons to the position of the atom in the periodic table. Now, the first thing we can do is we can look at the atom and say it's got 3 shells. Now, the fact it's got 3 shells automatically puts it in the third row of the periodic table. Okay, we say period 3. So the top period where hydrogen is, this is period 1, where lithium is period 2, sodium is period 3. So anything in period 1 has got 1 shell. Anything in period 2 has got 2 shells. Because sodium's got 3 shells, it will be in period 3. Now, the other thing we notice about sodium is it's got 1 outer shell electron, just 1 in here. Now that puts it in the first row, sorry, in the first column. Okay, which means it's in group 1. So just by looking at where sodium is, without looking at the number 11 or without looking at the atom, I should be able to say straight away, well, it's in the third period, therefore it's got 3 shells. And I can say it's in the first group, therefore it's got 1 outer shell electron. Okay, so the position in the periodic table tells you really everything you need to know about the electron structure of an atom. So for example, if I look at lithium, I know, well, it's going to have 2 shells, 1 electron in the outer shell. Okay, if I look at chlorine, I can say it's going to have 3 shells because it's in group 7, it's going to have 7 electrons in the outer shell. Now remember, when it comes to groups, okay, where it says 1a above hydrogen here, this is group 1, beryllium, group 2. I jump all the way across the transition metals to boron, group 3, carbon, group 4, nitrogen, group 5, oxygen, group 6, fluorine, group 7. Okay, so the periodic table is linked to the electron structure of the atoms. Just a reminder as well, in the final group, okay, group 8, we've got what's called the noble gases, okay, or the inert gases. Now these ones, because they're in group 8, they've got 8 electrons in their outer shell, except helium, which has got 2. But they've all got full outer shells. Okay, and that's going to be really important because the rest of this lesson is going to be about atoms trying to get to a full outer shell of electrons, because that's the position that every atom wants to achieve. It wants to become a full outer shell of electrons. These ones don't need to because they've already got that. Okay, so these noble gases, they've already got a full outer shell: helium, neon, argon. Okay, so helium's got an outer shell of 2 because that's how many go in the first shell. Neon's got an outer shell of 8. Argon's got an outer shell of 8. Okay, what this means is that these atoms are very stable and very unreactive. They don't react with anything. They don't bond with other elements. Okay, so they tend to stay by themselves. You know, like hydrogen will bond with oxygen to form water, while neon, helium, argon pretty much never bond with anything. And they're monatomic. Monatomic means that they don't join with other things. If you remember, things like oxygen always exists as a diatomic molecule, so O2. Oxygen bonds with itself to form O2. Well, you wouldn't find these atoms doing that because they're already happy with what they've got. They've got full outer shells of electrons. But all other atoms are going to try and lose or gain electrons to get themselves a full outer shell. Okay, and we're going to talk about how they do this. Okay, and they become an ion. So, for example, sodium. Sodium has 1 electron in its outer shell. So what it really wants to do is lose that electron. Okay, and once it's lost it, it's got a full outer shell. So sodium will lose the electron. The electrons are negative charge. So if you get rid of some of the negative charge, you're left with positive overall. Remember that positive charge is in the nucleus, the protons there. So for a neutral atom, which most atoms are originally, the number of protons adds up to the number of electrons. So there'd be 11 positives in the center and 11 negatives around the outside. But if it loses one of those negatives, it's now got 11 positives in the center and only 10 negatives around the outside. So overall, it's positive. So we're going to say that sodium becomes a positive ion because it loses an electron. So if you lose an electron, you become a positive ion. And this sodium is happy now because it's got a full outer shell. And it can give its electron away to another atom that might want to gain it. Okay, so anytime that atom becomes charged, either positively or negatively, we're going to call it an ion. Now, some atoms want to do the opposite. So, for example, we've got chlorine here. Chlorine's on the other side of the periodic table in group 7. And in group 7, you have 7 electrons in your outer shell. You see, we've got a bit of a gap on this chlorine atom where instead of having 8, we don't have 4 pairs, we have 3 pairs and 1 electron all by itself. So this atom, chlorine, would love to gain an electron. And it could gain it from something like sodium that wants to give it up. And when it does and it gains an electron, instead of being 287, it becomes 288. Instead of being called chlorine, we now call it a chloride ion. Okay, and this is what's present in something like sodium chloride. Sodium and a chlorine atom, which has actually become an ion by gaining an electron. Now notice this time, instead of a positive, it's got a negative charge on it. Okay, and there's a couple of things that we need to kind of realize when we draw ions. We normally put the ion in brackets. Now, I didn't do it on the last sodium one for the first example, but as soon as an atom becomes an ion, we put square brackets around the outside and we put the charge in the top right-hand corner. Okay, so this one is negatively charged, but -1, because it's only gained 1 electron. If it was to gain 3 electrons, it would become -3. And some atoms do that. For example, here's phosphorus. Phosphorus had 5 electrons in its outer shell, okay, in the diagram on the left here. Now, phosphorus wants to gain 3 electrons. You see the 3 crosses that I've added there, and that forms a phosphorus ion. Now, notice I've put it in square brackets, and at the top right-hand corner, because it's gained 3 electrons, it's now got a charge of -3. So if you gain electrons, you have a negative charge. Okay, if you lose electrons, you get a positive charge. Okay, so phosphorus gains 3 electrons. Electrons are negative, so it becomes -3. And we could have all kinds of different examples of this. We've got magnesium at the bottom. Magnesium has 2 electrons in its outer shell. It will lose them both to become a full outer shell, which is what all of these atoms want to do. And then it has a +2 charge. Okay. So remember, electrons are negative. If you lose them, that makes you positive. If you gain them, that makes you negative. So I want to go back to this periodic table again. Now, this periodic table shows you the ions that each atom forms. Okay, so for example, lithium, I've just highlighted it there, is in group 1. Because it's in group 1, it has 1 extra electron, which it wants to lose, so it will always form a +1 ion. Now notice, when it's 1, +1 or -1, we don't worry about writing the 1, we just write plus. And notice that everything in the group with lithium is also a +1, okay? Because all of those atoms have 1 extra electron, they always form a +1 ion. Calcium in group 2 forms a +2 ion. It's 2 extra electrons it needs to lose. When it's lost them, it becomes +2. On the other side of the periodic table, you're going to get the atoms that form negative ions. So oxygen, okay, has 2 spaces where it wants to take electrons. If it takes electrons, it's going to form a -2 ion. And if you look at within that group with oxygen, almost all the other atoms within that group will form the same ions. Okay. Now, right in the middle of the periodic table, the transition metals, these ones are much more complicated. Okay, so they don't necessarily form, the ions you would expect. So we're not going to deal with those at present in year 8 because they're a bit more complicated. But if you're in group 1, you form a 1+ ion. Group 2, 2+ ion. If you're in group 3, most of them form a 3+ ion. There are some at the top here, boron, carbon, silicon in group 3 and 4, which don't form ions, okay? But most of them form a 3+ ion. In group 4, some of them form a 4+ ion. In group 5, they form 3-. In group 6, 2-. Group 7, 1-. And remember, in group 8, they don't form ions at all because they've already got a full outer shell. Okay. Now, what I'd like you to do right now, I'm going to give you a little exercise to do, and you need to go onto Google Classroom and find the document called Turning Atoms into Ions. In a moment, I'd like you to pause this video, and you are going to have a go at drawing the ions on the sheet. Now, the first 2 on the sheet are done for you. So if you open it up, you'll see that there are atoms, for example, sodium, and they want you to change them into the ion. So follow the example that's been given on the sheet, okay? And when you've finished all of them, if you come back on to the video and start playing from where we've just finished, okay? I will be checking these after the lesson to make sure that they're all okay, and I can give you feedback on anything that any mistakes you've made. So please pause the video now, okay? Have a go at those that sheet, and then come back to this. Okay, hopefully that was okay and you didn't have too many problems with that. Okay, I'm just going to go on and we're going to talk about ionic bonding now. So hopefully we're happy with what's meant by an ion. An ion is an atom that gains or loses electrons, okay, and once it becomes charged, +1, +2, -1, -2, we call it an ion, okay? And although I've just been making you draw the entire electron structure of atoms, generally, to save time and make things a bit simpler, we only show the outer shells in these diagrams. So for example, sodium here, sodium has a structure 281, So really I should be drawing 3 shells, 2 electrons in the inner shell, 8 electrons in the middle shell, and 1 in the outer. Notice on here, I've just drawn 1. I've ignored the inner shells. Now that's because what we're going to talk about next is about bonding, about why atoms might join together and be bonded. Well, actually, it's only the outer shells that are important in bonding. So we're going to forget about the inner shells. For chlorine, the electron configuration is 287. If you look at the diagram I've drawn here, I've just drawn 7 electrons. I've ignored the 2 and the 8 inside. Now, sodium has 1 extra electron on the outside. It will lose it so that it's got a full outer shell. I know this doesn't look like it's full, but obviously the next shell in is going to be full with 8. So I'm going to call that a sodium plus 1 ion. I put my brackets in, I put a plus at the top. Chlorine is going to gain an electron, which I've drawn here. Sorry, it looks a bit scruffy. The diagram I nicked off the internet wasn't quite right. I had to add it myself. So I put it in square brackets here, and this becomes a minus ion. Now, one of the important things here is that in order for chlorine to gain an electron, it needs an atom that wants to give away an electron. So sodium and chlorine fit perfectly. Sodium wants to get rid of an electron, chlorine wants to gain it. So if you put sodium and chlorine together, what you find is they exchange electrons, and we're left with sodium plus ions and chlorine minus. Now, when we get these things, and the sodium donates its electrons to the chlorine, the positive and the negative ions will be attracted to each other. Now, I know in year 7 you guys dealt with electricity, and one of the things you were looking at was static electricity. And we looked at how charges can repel and attract each other. So things like the Van de Graaff generator, when you put your hands on it and your hair stands on end, that's because all of your hairs become negatively charged and they all repel each other. Because like charges that are the same, repel each other. Well, here we're looking at the opposite. We're looking at opposite charges. And opposite charges attract. So sodium is going to be attracted to chlorine. And that is the bond that is formed. The reason that sodium is attracted to chlorine and forms sodium chloride, common salt, is because sodium becomes a positively charged ion, chlorine becomes a negatively charged ion, and the two of them attract each other. Now, when that happens, we call it an ionic bond. Ionic because it's made up of ions, and the bond because they're being attracted and held together. So this is now a compound. Sodium is an element, chlorine is an element, okay? By exchanging the electrons and then bonding together, we've now formed a compound. And that compound can have very different properties from the elements that form it. Remember, sodium, very reactive, soft, shiny metal. Chlorine, okay, is actually quite hazardous gas, but together they form white crystal, solid, common salt. And let's look at some more examples of reactions then. Magnesium reacting with oxygen. Okay, magnesium has 2 spare electrons in its outer shell. Oxygen has 6 electrons in its outer shell, so it's got 2 spaces. So magnesium and oxygen, perfect pair. Magnesium gives 2 electrons to the oxygen, so magnesium becomes a 2+ ion. Oxygen becomes a 2- ion. We've got a positive, we've got a negative, and they're going to attract together. So magnesium donates its 2 electrons. You get an Mg+2 ion. You get an oxygen 2- ion, and they're going to attract each other, forming a bond. Okay, and that compound is going to be called magnesium oxide, which we looked at earlier in the year when we burnt magnesium. Now, this is a slightly more difficult example, okay, because magnesium also forms an ionic bond with chlorine. Okay, but if you look at this diagram, magnesium wants to get rid of 2 electrons, but chlorine only wants to take 1. So just have a think for a minute. How are we going to get around this? Magnesium's got 2 electrons that it needs to get rid of. Chlorine only wants to take 1. So what are we going to do to solve this problem? I don't know if you guys have come up with an idea yet. Well, the way that this works is magnesium teams up not just with 1 chlorine atom, but with 2. And magnesium will give 1 of its electrons to 1 chlorine atom and 1 of its electrons to the other. So we actually get 3 ions formed here. A magnesium 2+ with 2 chlorine 1-. Okay, and because of that, the compound that we form, it's not just magnesium chloride, MgCl. It's magnesium chloride MgCl2, because every magnesium atom needs to bond with two chlorine atoms. And I'm sure you've seen formula like this before, where you have twos and threes and things in the chemical formula. This is because we need to have the right balance of atoms in order that something like magnesium can give away all its electrons to the chlorine atoms. Let's go back to this periodic table again, okay, periodic table of ions. Okay, well, for ionic bonding, what's really important is you need to have atoms that want to get rid of electrons bonding with atoms that want to take electrons. Okay, so on this table at the moment, let's go back here. So I've put in these red and blue squares. Everything in the red squares are metals, and the red, all of those atoms want to get rid of electrons. Now in the blue square, okay, or the blue rectangle, sorry, we've got atoms that are non-metals and want to take electrons. Now ionic bonds only occur between one atom from the red rectangle and one atom from the blue rectangle. It always needs to be a metal and a non-metal. So lithium will react with chlorine to form an ionic bond. Okay, sodium will react with bromine. What you won't find are two metals reacting together to form an ionic bond, or two non-metals. There are other types of bonding, which we'll talk about in a later lesson. Something called covalent bonding is going to be the next, which actually occurs between two non-metals. But for ionic bonding, what we've been talking about this lesson, it must happen between something that wants to give up an electron and something that wants to take it. So again, I'm going to ask you to pause the video in a moment. I want you to go through this list of compounds. In fact, they're not all compounds, of molecules or compounds. And as you do so, I want you to decide, are they going to be held together by an ionic bond, or must it be a different type of bonding? Okay, so can you pause the video now, and I'll go through the answers in whenever you replay it. Okay, hopefully you've given yourself enough time for that. So in order to solve this, the key thing you're looking for is, does that compound have a metal and a non-metal in it? Okay, so all the ones in red are ionic bonds, or are held together by an ionic bond. And the reason being that they all contain a metal which wants to lose electrons and a non-metal that wants to gain electrons. So the metals are sodium, magnesium, lithium, calcium. Notice the metals always come first in the name. The non-metal parts, well, the chloride in A comes from chlorine, the oxide in B comes from oxygen, the fluoride in E comes from fluorine, and the chloride in H comes from chlorine. So those four in red have all got a metal and a non-metal part. Okay, now this is the end of my video, but it's not, I'm afraid, yet the end of your work. I want one more task that I would like you to do. So could you go back onto Google Classroom and open up the ionic bonding exercise? Now on the sheet, again, there's an example of how to do it, where I want you to take the two atoms to show me what the ions that they form will look like, okay, and to show me essentially how you form an ionic bond. There are also a couple of written questions on the sheet at the start and the end. I'm suggesting that you if you look on my Google Classroom post, that you draw these out, take a photo of them all together, and then upload it to Google Classroom as a single document, please. Okay. If there's any problems, then please either send me an email or write me questions in the Google Classroom stream. Okay. I hope that was helpful. Thank you very much.